Alright, everyone, we're going to continue on. We're going to add in some live tooling. We're going to make some flats on the step holder. So I've left off here at the end of the second op, and we're going to go ahead and add the geometry and then program the toolpaths to make a couple of little flats on this larger diameter, so we can use a wrench to tighten it in the tool holder that goes in the mill. So first thing we need to do is draw the geometry. So I'm going to go ahead and I'm going to switch my plane. I'm going to switch. So if I go to the top plane, I can't draw in this plane, so I need to switch to a plane where I can draw in this orientation. So that's going to be the right plane. So I hit the equal sign and then I do a right click top. Now I can draw. So right side plane, hit the equal sign to make it all current. Then I'm going to go to the wireframe tab and I'm going to draw a rectangle. So we're going to use a 7/16 wrench. Since this is a 1/2 inch diameter, that's the next size down. So 7/16 is 0.4375. Also, don't forget, you can just type in 7/16 and hit enter and it'll do the math for you. For the height, I'm going to go with just 0.6, something larger than this diameter. We just want two flats. We don't want to make a square out of the diameter. So, and then I'm going to choose anchor to center right here. And so then I will hover over and place it on the origin, just like that. Green check. So now I have the rectangle, and now I'm going to extrude that as a cut. So I'm going to go to Solids tab, Extrude. My chaining, I'm going to choose a full chain and click on the wireframe and green check. Alright, and so starting at the top here, we want to choose cut body, and then it's going the wrong way, so we want to reverse it. Alright, and my distance is going to be 0.75. And then when I do that, you see it's cutting out the middle, right, which we don't want. We want it to cut out the outside of the rectangle. So the way we do that is we come over to Advanced and we choose Thin Wall. And we're going to choose Direction 2. So we want it to only go to the outside. So if you hover over, it kind of shows you a little picture of what's going to happen if you choose that option. So what we want is direction 2, so it's going to cut to the outside of our rectangle instead of to the inside. So like that. Alright, the 0.1 should be plenty. If we look at our model preview, we got nice flats on there now. Looks good. Okay, so we'll go ahead and green check that. Alright, so now that's done. So what I'll do is I'll just go ahead and move this wireframe geometry to a different level and hide it, just so we don't mess it up. Because if you delete this geometry, then you're going to have a dirty model and you won't be able to save and all that good stuff. So I'm just going to go to my levels. going to Shift key, select the rectangle, then I'm going to go to the Home tab, to my Organize section, and I'm going to click on the Change Level. And I'm going to uncheck Use Active Level. I'm going to give it a new number. I call it level 10. And then I can click on the X and hide that. You can also give that level a name. I call it Flats Geometry. Okay, alright, so now let's move on to programming the cuts with the live tool. First thing I need to do is get my planes back to the correct planes. So go back to the Planes tab, and I'm going to click on Top for WCS, and I'm going to click on plus D plus Z for the C and the T planes, construction and tool planes. Alright, so WCS at top, construction and tool on the plus D plus Z plane. Okay? Alright, and now back to my toolpaths. So I come back over here, up to the top, turning, and then I have C axis, and I'm going to choose face contour. So the face contour is for a straight tool to make some sort of a shape on the face. So click on that. I'm going to choose my solid geometry selection. I'm going to choose single edge, and then I'm going to zoom in here, and I'm going to choose this edge on the left side, so I get climb milling going that way. And then on the bottom one, I'll choose the other direction, start from the right and go to the left. That will also be climb milling. Okay, green check, and then it kind of ends up looking like a mill toolpath parameter page. So I need to go and select my tool. So library tool, I'm going to use a 1/2 inch end mill. Right there, green check. That's going to be tool number 11 in the SL10. And so tool 11, and then I'm going to go ahead and update my speeds and feeds. 250 surface speed, 2.5 thousandths chip load. I'll change my plunge rate to 10. Alright, for cut parameters, we'll go ahead and use wear compensation, just like normal. We do not need any depth cuts. We do want to lead in, lead out. So just kind of go with my normal lead in, lead out, 40, 40, 60, and make the lead out match. So 40, 40, 60. And then multi-passes, I'm going to just add a couple of multi-passes. I'm going to do 2 passes at 15 thousandths and 1 spring pass. Linking, I'm going to change everything to absolute. And for my depth, I'm going to select here on the edge, and I should get minus 0.75, which I do. And then coolant is on, and green check. Oh, look at that, what happened there? That's weird. back plot. Looks like the tool is going right through the middle of the part. It's going the wrong way. So let's go back in, parameters, cut parameters. Oh, compensation is to the right. Well, that's not correct, right? We're doing climb milling, so compensation needs to be to the left. So left, green check that, and there we go. Now our toolpaths look like they're in the right spot. A little back plot, and much better, much better. Okay, green check, and save it. And that is that.